This presentation is on Chapter 5, Getting More Than Simple Columns. We will take a look at using expressions in our select statements. The topics covered in Chapter 5 begin with what is an expression. After defining an expression, we will take a look at specifying explicit values in an expression, the different types of expressions, and then finally, once we are comfortable with expressions, we will use them in a select clause, and we will end with what do we do when there is a null value in our data when using a select clause. To select more than simple columns, you need to create an expression, which is simply some form of an operation on a column involving number columns, character string columns, date columns, and time columns. It can use values drawn from these specific columns in a table with these data types, and it can also use constant literal values or a combination of the two. The type of data used in an expression impacts the value the expression returns. Every column in the database has an assigned data type that determines the kind of values the column can store and the operations that can be performed on the column's values. For instance, if the data type of a column is numeric, you can perform mathematical operations on that column. It's very important to understand the basic data types before you can begin to create literal values or even combine literal values with column values in an expression that is meaningful and that returns a proper value. Of the many data types, standard data types that exist, we will focus on these 5. In particular, of these 5, we will focus on character, numeric, and date time. This is our syntax diagram for a character string literal. A character string literal is just a sequence of individual characters enclosed in single quotes. Recall, on a syntax diagram, the begin point is a backward slash and the end point is a forward slash. A character string must be enclosed within single quotes, one at the beginning, one at the end. And this is an example of a character string literal. You see the beginning single quote and the end single quote. Here you see an example. The vendor's name is with double quotes for the space between R in vendor and S in vendor to indicate that this is not a quote that is used to denote the string literal. It is a quote that is part of the string literal. And here you see its use on the syntax diagram. The SQL statement would be select single quote, the vendor, double quote, S, name is, colon, single quote, comma, and column name, VIN name from table, which is vendors. This is the syntax diagram of a numeric literal, which consists of an optional sign, plus or minus, and the number can include a decimal point, the exponent symbol, and the exponential number. Here we see a numeric literal. We see one with the negative optional sign. We see the optional decimal point. And in this example, we see the optional exponential number. Now, I say optional because you are not required to only use decimals or only use numeric literals with exponents. That is why I say optional, because you can have a whole number as in 427. You can have a negative decimal number as in negative 11.253, or you can have a number to the exponent of a negative 3, as in the third example here. This is the syntax diagram for a date literal. The format is year hyphen month hyphen day. The example is single quote 2007, the year, hyphen 05, the month, hyphen 16, the day, closed quote. Notice the literal value is enclosed in single quotes. This is the syntax diagram for time. The format is based on the 24-hour clock. Here we have an example. Notice the time is enclosed in single quotes. We have 03 for the hour, colon, 30 for the minutes, colon, 25 for the seconds. Notice that the literal is enclosed in single quotes. This is the syntax diagram for the timestamp literal. It's simply the combination of the date and the time separated by a single space. Here we see an example. Single quote, 2008, the year, hyphen, 09, the month, hyphen, 29, the day, space, 14, the hour. Remember, we are using a 24-hour clock, colon, 25 for minutes, colon, 00 for seconds, single quote. Notice it is enclosed in a single quote. Now we can change the data types. A function we will use in this chapter is the cast function. You must be very careful when you create an expression to make sure that the data types of the columns and the literals are compatible with the operation you are requesting. For instance, you cannot add the number 2 to a column that stores data. That is why we use the cast function to change the data type so that we can add characters that look numeric. For example, a 2 saved as a character can be converted by using the cast function to a numeric literal, the number 2. This helps to ensure that the data types of the values in the expression are compatible. Without the cast function for conversion, we would not be able to do the operations on expressions with different data types. This is an example of cast, single quote, 2016-11-22, single quote as date. The assumption is 2016 November 22nd is stored as a character. We want to cast it as a date. We can do the same thing for time. We can take 03:30:25 and cast it in the time format when it is saved in the character format. Another example, the third one, we have 2008, September the 29th. The time is 14, which is 2 p.m., 2 p.m., 2:25 p.m., 0 seconds. We can convert this character string to the date time format. Now that I have covered data types and literals and the cast function, which allows us to convert data types, we can now move forward and discuss operations on columns and literals, which we call expressions. The expressions we will take a look at in this chapter are concatenation, mathematical, date, and time. Concatenation, what is it? It's a function like the cast function, but we do not have to use the word concatenation. We can simply use its symbol, which consists of two vertical bars. The SQL standard defines two sequential vertical bars as the concatenation operator. Keep in mind, this is the SQL standard. Commercial products like Microsoft's T-SQL and Oracle's SQL Plus may use a different symbol for concatenation. You can concatenate strings of column references by simply placing the operator between the two items. The result will be a single string. For example, if we use the concatenation symbol between the character string Mike and the character string Hernandez, the output will be Mike Hernandez. But notice there is no space between the first name and the last name. What we can do is include a concatenation of a space represented here between two single quotes. Now we have the string Mike concatenated with the string a blank space concatenated with the string Hernandez. The output is Mike space Hernandez. Let's look at this example using not only concatenation but also the function cast. Here we have product name, a column concatenated with a string sales for. Notice there is a space between the S in sales and a space after the R in for. This will allow us to read clearly product name sales for and then the value, which involves the use of the cast function on retail price, a numeric value cast as a character. Let's see what the output would be. Trek 9000 mountain bike, that's the product name. Sales for, we have the space before S and the space after the R, and then the retail value as a string. Mathematical expressions. They are simply mathematical operations on literals or columns. The SQL standard defines addition, subtraction, multiplication, and division as the operations you can perform on numerical data. The standard also defines common mathematical functions to calculate values such as the absolute value or the exponent or the log of a number. So we are not covering all of the mathematical operations that are allowed. We're just going to cover the few basic in this chapter: subtraction, addition, multiplication, and division. These are examples here. You have two numbers, 25 plus 35. You have two numbers, negative 12 times 22. You have two columns, retail price times quantity on hand. Two columns, total score divided by gains bold. And then you have a column minus a numeric value, another column divided by a numeric value. What we want to remember is the order of precedence when we are dealing with mathematical expressions. You may recall PEMDAS, please excuse my dear Aunt Sally, parentheses first, exponents first, multiplication and division are both first. You read left to right when dealing with multiplication and division for seniority, and then you also read left to right for seniority when working with A and S, which is addition and subtraction. So parentheses first, exponents second, multiplication, division, reading left to right, addition and subtraction, reading left to right. For the date expression, which is simply, again, operations that are performed on a column with the data type date with a literal, which is also a date. The SQL standard defines addition and subtraction as the operations you can perform on dates. Again, literals that are dates and columns with the date data type. Here we have examples of two dates with the operator minus. So we have 2017. The month would be May. The date, our day is 16 minus 5. Again, we have 2017. The month is November. The day is 14 plus 12 days. We have a column which we must assume has the data type date, and we're adding 90 days to it. We also have the formula estimate date minus days required, two columns with the date data type. The next example are two literals within strings, enclosed within strings that are dates. And then the final example is again two columns. The assumption is that they have the date data type and the operator is subtraction. The time expression is very similar to the date expression. The operations that are allowed according to SQL standard are addition and subtraction. Examples that we have here are two string literals with the operator plus, two string literals with the operator minus. The third example is a column with the operator plus with a string literal. And the last example consists of two columns with the minus operator. Keep in mind, the columns are assumed to have the data type time in this example. We have reviewed data types and literals. We have just reviewed expressions, and now we're going to take a look at expressions in select statements. Recall our select syntax diagram from our previous lesson. Keywords are highlighted in yellow. Literal entries are highlighted in pink. We are going to focus on the column name, replacing that with an expression that includes the column name and another column name or a literal, but also includes an operator. The syntax diagram for the select statement with an expression in the place of just a simple column is shown here. The keywords are highlighted in yellow. The expression, column name, the literals are highlighted in pink. When you use an expression in a select statement, the result is considered a new column. Since it is considered a new column, according to the SQL standard, you can add a name to the new column by using the keyword as. This is an example of a select statement with an expression. We are selecting the first name, concatenated with a space, concatenated with the last name. We're using the keyword as to name the result, which is a new column, employee name. The next column selected is employee number, followed by employee city. In the from clause, we have the table identified, which is employees. Recall with our standard select statement, with the simple select statement, we selected just simple columns in our exercises before Chapter 5. We also selected literal values, and now in Chapter 5, we are selecting value expressions. And here you see the previous example as an example of a select statement with a value expression. In the select statement, we can also include a function. Here we have an example with select a column name, order number, comma, the cast function, which is casting the ship date minus the order date as an integer. If we assume that ship date has the data type date and order date has the data type date, this calculation, this subtraction of the two columns is correct. What the cast function is doing is taking the result, which is a date, and converting it to an integer. With the as, we are renaming the result to days to ship. And of course, we have our from clause, which includes our column name. Sometimes our result set of our value expression or even of just a simple column may contain repeating values. If we do not want the repeating values, we can use the keyword distinct to eliminate the redundancy. Sometimes a column within a table may have a null value for a row. A null represents a missing or unknown value. Important, it does not represent a zero. It does not represent a character string of one or more blank spaces, which we do use in our concatenation, but it's important to understand it does not represent null. A null does not represent a zero-length character string. An operation involving a null always evaluates to null. Let's take a look at a few examples. Here we have in parentheses 25 times 3 plus 4 equals to 79. But look at the second example. In parentheses, we have null times 3 plus 4 equals null. You may think null times 3 equals null, which is correct, but then you have null plus 4, and that is, again, null. The third example, 25 times null plus 4, 25 times null within parentheses is executed first. The result is null. The result null is added to 4 and gives a result of null. Essentially, an operation involving a null always evaluates to a null. We covered in this lesson what is an expression, specifying explicit values, the different types of expressions, and using these expressions in a select statement. And finally, we addressed the calculations with the null value. This week's assignments include a Chapter 5 quiz and a programming lab assignment for Chapter 5.